So, welcome to the session. Today we will talk about vector data analysis. Like in the previous lecture, we discussed about what vector data is like whenever we are representing the feature on the surface of Earth using point, line, or polygon. That's what that model of representing geospatial data is what we were calling vector data model, right? So then we discussed how do we how do we read uh, like then we discussed that there are vector data is available in multiple formats, right? So then we discussed about one of the most important or one of the most popular format of vector data, that is a shape file. Then we saw how do we read a shape file and how do we subset and all. Then small part of visualization also we did. So in today's lecture we will see in detail like how do we create beautiful maps using geopandas on vector data create beautiful maps from the vector data using geopandas. Actually geopandas internally it provides a high level interface for matplotlib. On the back it uses matplotlib only, but it provides a very high level interface, like you need not call the functions directly on the matplotlib. Directly from the geopandas geodata frames you can directly call those low level matplotlib functions, right? As you said that like this is the network of Delhi Metro Rail, Delhi DMR, the Delhi Metro Rail Corporation's route information, right? Like that we are representing as something called vector. So for this anyway, GeoPandas automatically comes installed in Google Colab. Then I am installing another library called Map Classify. That is just for using for doing classification, right? You can start with classification. I think it is already there. So then these things are all like normally what we uh, import at the starting of this. So first I am driving my first of all I am mounting my Google Drive. Then other things like pandas, that some tabular data if you want to manipulate something. Then GeoPandas we are importing and calling it as GPD. Then OS, NumPy, and Matplotlib just for plotting. And so then I'm just changing my working directory to the directory where my data is available. Right now, let us see how do we create maps and some plots using GeoPandas. So here I am first I am reading a file called state underscore boundary dot shp. So this is a shape file of in India. So it shows the boundaries of all states across India. Right. So then GeoPandas provides a very high level interface to the Matplotlib library by for making maps. Mapping shapes is as easy as using plot method for GeoSeries or GeoData frame, that whatever we have seen yesterday. Right. So now let us first read a vector file, like because this is a shape file, so like gpd.read file, and pass it the name of file which we want to read. And suppose if we want to inspect the file, we call india.head. So then it gives this, like these are all non-spatial attribute like state, so that specifies the name of that state, then the legend associated with the state, then shape length and shape area. Then the last column is the geometry, as we discussed yesterday that geodata frame is the extension of pandas data frame with an additional column called geometry. So that held that stores the geometry of all features which we have stored in our shape file. Right. Now plotting this. So as we said that there can be more than one geometry column inside our geodata frame, but out of those all geometry columns, one column will be designated as the geometry of the geodata frame, right? So because what is the advantage of being setting a geometry? So like you need not call specifically geometry. Like if you call any geometric operation on the geodata frame, that all geometric operations will be automatically done on the a column designated as geometry of your column. Like here I am calling in your my geodata frame dot plot. Right. So what it does, it looks for uh, for the geometry column and just draws the geometries which are specified in that particular column. Right. So now if I say India dot plot and I specify color, so it's fills all these uh, boundary, or fills all these shapes, or the fill color is green. And so similar way, suppose if you want to change the color of edges or the color of face to like different color, then you can specify to the plot two more arguments like edge color and face color. Right, now if I do this, now the edges will be drawn in black and the faces will be drawn in the red color. Like this, you can specify any color which you want. And suppose if you don't, if you just want the, you don't want the fill color, then you can specify face color equal to none. If you pass the face color equal to none, you will see a graph like this, right? So depending on your visualization requirements, you can uh, pass these values of these arguments, right? Then this is also same only. There is a boundary dot plot, right? That you will specify color and any other thing, right? Right, so India dot boundary dot plot. So boundary also will be, so India dot boundary, it calculates the boundary, and then the plot calculates the plot, shows the plot of this. Now, then similar way, like this is just we have drawn the geometries. Now, suppose if you want to make Choropleth map out of these, like suppose these are some geometries, and what happens, you want to color these things such that this conveys some information, right? So, GeoPandas make it easy to create Choropleth maps, also map where color of each shape is based on an associated value. Right now, till now, whatever we were doing, we were just coloring the faces or edges, faces basically based on like with the same color. Right? So those colors were not carrying or conveying any information. Right? Suppose if you want that color to convey some information, like suppose if you want, if the population of the state is you want to make a choropleth map out of this based on, like say there is a column in your data frame that specifies the population of every state of the country. Now suppose if you want to fill the fill each state the color, give each state a color based on the population in that state, right? So what we can do, while calling the plot function, we can pass another argument, column is equal to shape area. So what happens in this case, the color of each face in the boundary will be chosen based on the area of the shape. Now you can see that all these states have been given or color have been drawn with a different color, right? Now anyway, now as you can see that if you there is no legend attached to the map. Without legend you cannot read the map. Right now, if you see what does this green represent, or what does this dark blue represent, we do not know. So first thing is we must attach a legend that specifies like this color, what the value this particular color represents, right? So if you want to specify that, you can specify like legend argument, legend is equal to true. If you say that, it places a legend as well attached to that. Like this is showing that this yellow color is 3 into greater than 3 into 10 raised to the power 11, and this is the color scheme. Then you can change the color orientation of legend and any other things. Actually, for that, when you call the plot function, there you can specify another keyword argument, or say dictionary as legend keywords. Right, so an argument called legend keywords. To this, you can pass a dictionary that you can specify multiple arguments like label, what label you want to give, then orientation, then figure size if you wish to. Figure size also you can specify here. Right, like this you can specify color, then you can make it horizontal and another thing like whatever way you want to make. Then similarly, like this is you have it is drawn with a default color map. Right now, suppose if you want to change the color map, like you want the faces to be colored based on a different color map, then you can specify another argument to the plot function. Color map also you can specify as an argument to our plot function, right? So now the colors are based on the accent color map. So now next thing comes, like the way color maps are scaled can also be manipulated with the scheme option. Right now, how the color maps scaled. So how the word, like suppose if you want to change, like if uh, from this range to this range make this color, from that range to another range make that color, right? So the the way color maps are scaled, can this also you can manipulate quite easily using there is another option while when you call the plot, that is called scheme option, right? The scheme option can be set to any scheme provided by the map classify. Now how do you want to classify your entire, like we have chosen, we want to make Choropleth map based on some one column, right? Now how do we how do we scale the values in that color to make as a scheme. So there is, we need to specify an argument called scheme. So that scheme will classify those numbers by different schemes. Like you can make it as equal interval. Like if you have, your column has certain range like 0 to 1000, right? So then you can make it equivalent in interval, like you can break into five classes of 200 at 200 difference, or you can make classes like Fisher-Janks sampled, head tail breaks. So there are different schemes with which you can classify the range, right? So the classification, you can say that classification scheme is a method of binning continuous data values into 4 to 7 or 5 classes and map those classes to a color palette. Right? It's like once you have a continuous range, then you can use this classification scheme like that. That is the classification scheme. That is the method for binning these continuous data values into 4 or 7 classes. How do we break that continuous values into different classes so that we can give every class a different color, right? So these are the different commonly used classification schemes. Like one of that is equal interval. So equal interval, what it does, it makes equal size data ranges, right? So entire series it will break into equal size data ranges, like maybe 0 to 10, 10 to 21, 20 to 30, etc, right? So it is best for the data that is spread across entire range of values, so it can be easily understood by the map readers as well. So what are the cons? Avoid if you have highly skewed data for a big outliers or a few big outliers, like there are some few big outliers in your data, then this equal interval scheme fails, because that in case of skewed data, what you will see the color map will not look good. Then another scheme is quantiles. That's what you can do then, equal number of observation each in each bin. So equal interval was we are breaking entire range into equal interval in equal interval ranges. And in case of quantile, what do? We break the entire series such that every bin gets an equal number of samples, right? So this is what are the advantages of this. This looks nice because it is best it best spreads colors across full set of data values. It is often the default scheme for mapping software. So what are the disadvantages of this? Bin ranges based on the number of observation, not on the data values. So thus different classes can have very similar or very different values. So then there is another technique I call like natural color, natural breaks or something. So what natural break, the advantage of natural breaks, it is it minimizes within class variance and maximizes between class differences. Right. So it minimizes within the class variances and maximizes the difference between class differences. So typical methods are Fisher-Janks. So pros are great for exploratory data analysis because it can identify natural groupings. The disadvantages, it class breaks are best fit to one data set, so the same bins cannot always be used for maybe multiple years or something like this. Right. So now how do we use this classification scheme? Like plot, and you need to pass here another argument called scheme. So in the scheme you specify the scheme whatever we have discussed about, then either of that scheme you can specify. Right now you can see that these are the ranges. Then you can specify here equal interval or whatever you want. Then similar way, natural breaks, if you want to do, you can. I've added a column and we have created natural breaks as well, like this you can. Then suppose some of you see that in your Choropleth map, some data is missing, right? So that also, suppose if you want to convey the meaning that the data for a certain part of this geo series or geo data frame is missing. Let's suppose from our data set, if we inspect, Our data frame contains the state boundary and the population of, say we have filled up some fixed population to every state. Now suppose if we want to, like, suppose what we want, like for certain some state, suppose if data is not available, right? So that you suppose you want to mark it on the map. How do we do that? So first of all, what we are doing, I'm just removing the population information from say state of Assam, right? So I am setting it np.nan. So then while calling the plot function, you can specify another argument called missing keywords, right? So wherever the values are nan in your geo data frame, those will be displayed like this. Here you can specify missing keywords, your color as color, then you can specify hash, what hash to be used, and label, you can say that missing values. Now if I plot this, you can see that for the entire Assam, it has shown with a dashed hatches, right? Like it gives a here a legend as well, like missing. These are the missing values. Like this, you can create very beautiful maps depending on your requirement. Then, as we discussed yesterday, like some of the vector formats only allow a single layer in a file, right? But there are certain file formats which allow more than one layer also in this. So similar to this, now till now we have just drawn a single layered map. Now suppose if you want to draw a multi-layered map, like say you want to draw the boundaries of states of the India, and there and then suppose if you want to, on the top of that, we want to display the capital of each of the state as well, right? So then in that case we need to create a multi-layered map, right? So now here I have two files, like state boundary.shp and state headquarters.shp. So was one thing you must ensure before plotting two layers, creating multi-layer map, you must ensure that both of the layers are sharing the same projection information, like so that they have same projection. So they must have same projection. Otherwise, if they are not aligned, then they will go somewhere else, right? So before making a multi-layered map, you must ensure that the data which all we are going to use there must have the same projection. Right now we are reading the file, and let us inspect their CRS. So how do we inspect the CRS? By calling geodataframe.crs function. Right, so it says that the projection system in this is projected CRS with these parameters. Similarly, let's say state headquarters.crs. So that also is in the LCC WGS 84 projection. Right, it means that these both of these layers are in same projection system. Right, now let us see how do we create a multi-layered map, as we discussed in the matplotlib lecture. Like, so first we need to, in this case, first we need to explicitly create a figure and axis. Right, so by calling plt.subplots, we are creating a figure and axis. Then on our geodata frames, we are calling the function like either India or state headquarters dot plot, and we are specifying or passing it as an argument axis on which to draw these plot, right? So here we have created an axis. So India dot plot, we are specifying that just you draw this plot on this part of this axis. Right now, to both of these plots, we are passing the same axis, so they will be drawn on the top of one another. Like here we can say that we have drawn the boundaries of all states, and we are showing the headquarters of each of these state as a point layer. Right, like this way you can create a multi-layered map. Then similarly, if you want to create a interactive map, like as we saw yesterday, right? So we have another district boundary dot shape, and suppose if you want to just clip the districts of Gujarat state, right? So then if I call the explore function, then you can see that the interactive web-based map opens where all these things will be displayed, right? So you can see like this. Then suppose if you want, like once on clicking on this or hovering over this boundary, it shows something like this. Now suppose if you want to display some other information while hovering over it, then you can specify another argument called gdf.explore, which column to use for coloring, then tooltip what you want to show, pop up whether true or false, and on the base map if you want to show something, that also can be done. There are many other options instead of OSM. Suppose if you want a different color map like this, you can create very beautiful maps using GeoPandas and associated libraries. Right. So now let us see how do we manage projection using GeoPandas. So what might happen, sometimes you might get data from different sources, and all these data may be in different projections, right? So why? Because so then as we said that before doing any analysis or visualization, first we need to bring them together to a same projection system so that we can compare or align them location by location, if they are in same projection system, then we can draw them on the map, or then do any analysis with them. So as all of us must know, like CRS is a coordinate reference system that describes how coordinates in the geospatial data set relate to the location on the surface of Earth. Right. So generally, a geographic CRS consists of a 3D model of the shape of the Earth and the other associated parameters like eccentricity, semi-major axis, and semi-minor axis. Then projection system can be a projected coordinate system that consists of a geographic CRS, a map projection, and related parameters that are used to transform geographic coordinates to 2D space, right? So basically we have two types of projection system. One is geographic and projected coordinate system. Now let's see how to identify the CRS of a data frame. That we have seen that just by calling our geodataFrame dot CRS function, we can query in which projection system the data is there. So here it is in WCC WGS 84. Now this is querying the projection system. Now suppose if you want to initialize the projection system, right? So then we can specify the projection system by using its EPSG code or PROJ4 string also. Like if you know the EPSG code of a projection system, then by using the EPSG code of projection system also we can assign that projection to the geodata frame, or the otherwise like either from PROG4, or there are many other ways for defining the projection that also can be used. Right now, first what I am doing here, I am first setting the CRS of the India geodata frame to none, and if you query, it is showing that none is there. Now suppose if you want to, now let us next suppose if you want to assign a new projection system, then you can call india.crs is equal to assign it, maybe it's EPSG code or whatever way you want to assign that. Like here we are saying india.crs init EPSG 4326. Like this you can assign a new projection system to the your shapefile. Now let us see how do we reproject. So reprojecting is the process of changing the representation of location from one coordinate system to another coordinate system, right? So a geodata frame can be reprojected using to_CRS command. And so here I am just reading first the vector file, then querying its projection system. Then suppose if I want to reproject it to say EPSG 4326, then what function I need to call? Our geodata frame dot to_CRS. If we call and pass it the EPSG code of our destination projection system, then it can be specified like EPSG is equal to 4326. Now if I call India reprojected.crs, it says EPSG 4326. Right now if we project them together, so this is in LCC WGS 84, and if I call, this is in geographic coordinate system. Here itself you can see that the numbers are in meters, so very large numbers, and these are the latitude and longitudes. Right, so now we have discussed about how do we read vector data, right? Now suppose if you want to write vector data, like suppose if you have data available in some CSV file, like as we have seen the location of air quality monitoring station across Uttarakhand. Like suppose such kind of data, if you want to convert to vector data format, that also can be done quite easily. And so here I have the same file district_boundaries.shp. I am reading that file and I am just filtering the Gujarat. So this is my Gujarat. So I'm just extracting the boundaries of Gujarat. And if I see Gujarat dot head, so all the district boundaries of the Karnataka. Now suppose if I just extract these only columns and Gujarat dot plot, if I see like these are the different districts of Gujarat. Right now we have created a geodata frame like by choosing say. So I say Gujarat dot head. So like these are the some non-special attributes of the Gujarat geodata frame, like the name of the district, state, remarks, and there is another column called geometry. Right now, suppose if you want to write this geodata frame to the to say save shape file, then you just need to specify call the function or your geodata frame dot to underscore file and pass it the name of your shape file, right? So like I want this geodata frame to be written to a file called gujarat.shp, then it can be written. Now this save file will be there. So I am on server directory. So DLP data and India. DLP data inside India. Gujarat. So here you can see a file like gujarat.shp, gujarat.shp, and other files are created. Like this, like just by calling to underscore file, you can write a geodata frame to a vector data format, maybe any format which you are interested in. Okay, so let's see the next part. Then to underscore file gujarat.shp. Then similar way, suppose if you want to write a GeoJSON file, then you can say that okay, this particular geodata frame I want to write it as GeoJSON. Then you can say gujarat.geojson, and but there only you need to specify another argument driver. And so ISRI save file is by default is the driver, and if you want to write into a different format, then you need to specify the second argument called driver. So in that you need to specify the name of your format, right? So so similar way, suppose if you want to write some a multi-layer file, right? So suppose if you want to write district boundaries and district headquarters, like I have two layers here. One is the district boundary of each district, and another is in the headquarters, that is the point layer. Then suppose if I want to write them to say geo database file, right? So then I need to call like I am first reading this file. First I am just reading those files, and if we see district boundary dot head and district headquarters dot head. So these are two different layers. So for calling the function, we need to call district underscore boundary dot to file. So there we need to specify the name of geo package, name of the geo package, then layer, what layer you want to give the name while storing it, and the driver you can say gpkg. And the same function you can call once again, right? So Punjab dot district headquarters dot to underscore file, like your data frame dot to underscore file, and specify the name of geo package in which you want to write, then the name of layer what you want to give, then driver gkpkg, right? So like so this was all about reading and writing, and how do we create basic maps using geopandas. Now let us see some basic geospatial analysis. Anyway, we did it yesterday as well. For today also we will do some basic geospatial analysis. So in spatial analysis, our goal is not just to make nice maps, but our aim is actually run analysis that leverages explicitly spatial nature of the data. And the process of doing this is known as spatial analysis. Uh, 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 so spatial analysis is all about leveraging the explicitly spatial nature of our data by extracting useful information from our from your vector data by applying different spatial geospatial techniques, that what we call spatial analysis. So to construct spatial analysis, we string together a series of spatial operations in such a way that the end result answers our question of interest. Like, so generally only one or two spatial operations might not be sufficient for getting the answer from the data, for getting the answer from the data, whose for getting the answer to the question for getting the answer to the question which we are looking for, right? So you may need to apply multiple such transformation one by one together, right? So these are there are many such operations, that what we call spatial queries. So basically, spatial queries can be of measurement type, relationship queries, or relationship queries. Measurement queries mean like what we can ask: what is the feature A's length, what is the feature A's area, perimeter, distance of A from B, and so on. Right. So then there you can fire another kind of query called relationship queries also. Like, is feature A within feature B? Does feature A intersects with feature B? Feature A crosses feature B, or etc. Like this. Either you can query measurement, your query can be a measurement query or can be a relationship query. So here we are reading the same file once again, and we are attaching some new area by calculating the area, and see that based on the polygon, the dot area function has calculated the area of each of the feature and populated our geodata frame, right? So then similarly, suppose if you want to create a new column called new underscore area, in that you want to assign the area, that also can be done quite easily. Right, so a new column with name new underscore area must have been created with the values which we calculated. Right, now suppose if you want to create some basic geometries yourself in your code, right? So for that we need to use the function package called shapely.geometry, and that shapely.geometry you can create a geoseries. So a geoseries can have, as we discussed, that can have multiple features. Right, so here if you see here, we are creating a geoseries that contains a polygon, a line string, another line string, and a point data. Right, so if I call s dot plot, you see something like this, right? A polygon and different line strings. Then similarly, if you want to draw just a line, so now you are just getting all the lines which intersect, like from this all the boundaries which are intersecting with the line. And so this way we can do some basic geospatial analysis using pandas. Now let us see some like now we are reading the same file, state boundary and major towns, right? So we are reading the same two files. Now suppose now we have two different layers, like one is showing the boundaries of each state and another one is the major towns across India, right? Now suppose if you want to extract only the towns which are intersecting with the state of Andhra Pradesh, like you want to just extract the urban centers of Andhra Pradesh state only, right? So what we are filtering, we are first filtering the Andhra from our entire data frame. Then what we are calling towns dot within. So towns also is a geodata frame that we have written town, that is a point layer. So then what we are doing, towns dot within. So what it does, it picks for each and individual feature in the towns geodata frame. It picks up one and checks for all the frames, all the features say in Andhra, and if they are intersecting with one another, then it says that okay, this town is in Andhra. Right, now if you call Andhra underscore towns, and if we plot them, you can see that these are the major towns of Andhra Pradesh, right? So similarly, suppose if you want to do some proximity analysis, like suppose if you, like here we have state boundary, major towns, and state headquarters. Now suppose if you want to extract information about like which all major towns are coming within 5 kilometers of state headquarter or within 10 kilometers of state headquarter or whatever. So what we need to do for that, we need to do just create a buffer around the state headquarters and then intersection of towns and the buffer. And so that's all. With that, we get all the towns which are which are in the vicinity, say in the vicinity of our state headquarters. So I'm reading all these files. Now around state headquarters, we are creating a buffer of say 10 kilometer. Let's state headquarters dot buffer distance is equal to 10,000 if we create, and if we just try to plot this. Right, because this is the distance is very small, so because of that these buffers are shown here. Right, now suppose if you want to calculate all towns which are near headquarters, we can call towns dot within intersects or whatever you want. Then headquarter buffers dot unary union and town headquarters we are calculating, and if you plot them together, like you can see that these were the headquarters. And these are some cities which are within 10 kilometers of the headquarter of each state. Like this, we can do some proximity analysis as well. Then suppose if you want to explore them together, like which all towns are there which are near to the state capital. And then you can explore it on the interactive folium map as well. Then these, anyway, we have discussed yesterday, these geometric operations already. Suppose if you want to create a convexel, so that is a representation of the smallest convex polygon containing all the points in the object unless the number of points in the object is less than 3. Suppose if you want to create a convex hull around all features in your geometry, so like you want to make a representation of the smallest convex polygon containing all the points inside your geometry, then as we discussed yesterday in your geodata frame, you just call convex hull function and you can plot that, so it creates a convex hull. Similar way there, if you want to create an envelope around your geometry, then you can call envelope dot plot. And suppose if you feel that your geometry is too complicated and you want to simplify and you want to preserve topology as well, then you can say like within this, by this tolerance, simplify my geometry. Then you can call dot simplify, and if you see the simplified geometry, so it looks like this. So with this we come to the end of today's session. So I will just briefly summarize what we have discussed. So today our basic idea was creating maps from the vector data. So first we created some very basic map that were those maps were just drawing the boundaries. So then those boundaries we are coloring with different things. And suppose in the next case we saw how do we create choropleth maps. So maps where the color of the face of the feature, if it is this conveying some information, right? So that then we saw how do we create choropleth maps, layered file like geo package or a shape file or a GeoJSON file, right? So then we discuss about some, then we did some proximity analysis or some intersection operation when we tried like we just like we had two layers. Right, one layer was showing the all state headquarters, another layer or say major towns across country, and the second there was another layer which were containing the boundaries of different states. Then we filtered, like suppose if you wanted to filter all major towns which are coming under Andhra or something like this, we can do some spatial analysis. Then the second part we see some basic geometric operations like creating convex hull, envelope, and so on. Right, so with this we come to the end of the lecture. So thank you very much for attending. If you have any questions, please post them on the chat box. So thank you very much.